My name is Darren Joseph. My number card matrix is 07DTK23F1002. I hope you guys will understand the question that we are going to be solving today.
Hi, I'm Max Sir, and my matrix number is 07DTK23F1018.
Hi, my name is Ainur Alimi binti Idil, and my matrix number is 07DTK23F1030.
Our goals. Our first goal explaining about what is volume and the resolution, also then the use of it on real life. Our second goal is showing everyone how to solve and answer a question about volume and resolution in the integral. Our main goal, making sure everyone who seeks this presentation can understand and apply this method in their daily life. The introduction of this our presentation right now is the volume of the revolution. The term volume of the revolutions refer to the concept in the calculus and geometry where a two-dimensional shape is rotated around a specific axis, creating a three-dimensional solid. These solids often refer to as a solid revolutions, retaining certain properties of the original shape, but its volume is calculated differently.
Why is it so important? Understanding and calculating volumes of revolution is crucial in various fields such as engineering, physics, and manufacturing. For instance, it helps in designing and analyzing objects with rotational symmetry like wheels, bottles, and machine parts. It is also essential in medical imaging and computer graphics, where 3D models are created from 2D cross-sectional data. Now the application and the examples. To bring the concept to life, consider the example of a vase. By rotating a curved line that outlines one side of the vase around the central axis, we can form the complete three-dimensional shape. Using the method of volume of revolution, we can accurately determine the vase's volume, which is essential for design and manufacturing. Now, let's move on to the next slide. Real-life application of volume and revolution. Engineering and architecture. Engineers and architects frequently use volume and revolution calculation when designing and constructing various structures, such as buildings, bridges, and tunnels. Understanding the volume of materials needed and the shape they create when rotated help ensure structural integrity and efficient use of resource. Civil engineering. Civil engineers use volumes calculation extensively in projects such as road construction, earthwork, and land development. Understanding the volume of soil, gravel, or concrete required for construction helps in planning and budgeting.
So, diagram below shows a region which is enclosed by a curve y equal to x plotted by 2 and a line y equal to x plus 2 that is rotated through 360 degrees on the x-axis. Show the solution to find the volume of the solid form. But before solving these questions, there are 3 steps. Step 1, write down the formula. Step 2, integrate them. And step 3, put in the limit value inside the formula. And now, this is the step 1, which is to write down the formula and then write down the limit value that what's have in the graph. So, the formula is going to be pi, the limit, x2, x1, and then y followed by 2 dx. So, since I told you guys the first part is that there are already y that is given. And then the limit is going to be on the x-axis. Since the question is talking about in the x-axis, so take the x-axis limit, which is negative 1 and 2. Now, moving on to step 2. Since we get the formula, then we are going to insert the y, which is y equal to x2, and then y equal to x plus 2. Since there's 2y, subtract these two in the formula. And then after that, since the pi and the limit to negative 1 is the same, we can combine it. After combining it, it will get x multiplied by 2 plus 4x plus 4 minus x multiplied by 4. Now, moving on to step 2, which is to integrate them. After we combine them, then we should integrate them. Then how do we integrate them? X multiplied by 2 integrate, it will be x multiplied by 3 over 3 plus 4x. 4x integrate them, it will be 2x multiplied by 2 plus 4. 4 integrate, it will be 4x. And x multiplied by 4 integrate them, we will get x multiplied by 5 over 5. And then now, moving on to the step 3, the second last step, which is to insert the value of the limit inside x. So change the x in the function that we already integrate into 2, and then subtract it into another limit, which is negative 1. So after that, we already get the things that I have written here, which is the limit 2 and the limit negative 1. Insert these both in x. Use the calculator to find the value. So for the limit 1, which is 2, for the limit 2, you will get 184 over 15 pi. And then for the limit negative 1, you get negative 32 over 15 pi. Then after that, after you get 2 of this value, subtract them. After subtracting them, you get 72 over 5 pi. So this is the final answer. So now, the conclusion. In conclusion, volume and revolution concepts extend for beyond the realm of mathematics, finding practical various fields such as engineering, manufacturing, medicine, and design. These principles underpin essentials processes, from structural design to product manufacturing and medical imaging. And then the second paragraph talks about understanding volumes and revolution empowers us to solve complex problems, and then optimize designs and innovate in diverse sectors. As we continue to apply this concept in real-world scenarios, we unlock new possibilities for technological advancements and societal progress.
Alright, thank you.